Okay, so this is just going to be a short video about covalent compounds. Before I start, I did want to mention that I've attached these slides to Schoology, so you can kind of scroll through these if you need to. And at the beginning, I do have the ionic compound notes. So if you have questions or need to fill in notes from yesterday, you do have a little bit of that there. So I'm going to go ahead and start with the covalent compounds. So there are kind of two groups of covalent bonds. We have something called network covalent. These are structures. They're covalent because they are nonmetals. Mostly, usually they're carbon sheets, and then they do share electrons. But the way that they share, it actually forms like this network. So it's very similar to that crystal lattice that we talked about with our ionic bonds. But in this case, this bond is very strong. It's not as strong as ionic, but it's much stronger than other covalent substances. What we're going to talk about, or mostly what we're going to talk about, are these molecular covalents. So these are like what you would normally think of, like individual molecules and things like that. So we're focusing on molecular covalent. We're not so much worrying about the network covalent, but I just wanted you to be aware that they are there. So just some properties. We kind of talked about a little bit about this yesterday with the chart where you kind of looked at the data for ionic and covalent bonds and you separated it out. So covalent bonds are formed by sharing of electrons. So you should have seen that in the simulation that you completed. You should have kind of seen how they share electrons. It's kind of like they're it's like a push and pull for sharing. So it's almost like they're not really sharing nicely. It's almost like they're actually fighting over the electrons, and neither one of them want to let go. So sharing is really a more friendly word than what's really happening. But because they're sharing them and they don't have these really strong crystal lattice structures, they form these kind of loose attractions. Some of our properties are different. So they can still dissolve, but some of them can't. Most of the ones that can't, those are our network covalents. For example, sand, diamond, graphite, those are all network covalents. And I mean, you've seen sand before. Sand does not dissolve in water. But what we're talking about are molecular covalents. Most of them can dissolve. Those are things like sugar. Okay. And then they also have these are different from our ionic properties. This low melting point, sometimes they're soft, and they're non-conductive. Even when they're dissolved. So this is because they don't form that really tight crystal lattice like ionic bonds do. That's what leads to these different types of properties. So just make sure you have those kind of from yesterday. So after going through kind of the naming compound activity on the page before, you should have kind of figured out some rules for naming covalent compounds. You probably noticed that they're very similar to ionic. So just like ionic, we're always going to name the first element. And then our second element, we're going to change that ending to "ide." Some of them, it gets a little tricky on where you put the "ide." If you want to think of it like you always say the first syllable of the element, and then you just take everything else away and you have "ide." So it's like oxide, sulfide, phosphide, fluoride. So it's always kind of that first syllable and then "ide." Nitride, okay, not nitrogenide or nitrogide. It's just ni and then tride, if that makes a little bit of sense. And then we saw that we use these prefixes. So whereas with ionics, right, we had those charges and then we crisscross them in order to write our formulas. For our covalent compounds, we're not going to do any of that. So that's kind of nice. You don't have to worry about any of that. We are just looking at these prefixes to tell us how many of each element there are. So if you need to pause here so you can write down these prefixes in the notes, go ahead and do that. That's just the key. So let's do just a few little quick practice ones, and then you have some independent practice that you can do yourself. And hopefully these won't take you too long. So let's look at this first one. So we're just going to name our first element, nitrogen. We're going to name our second element, but remember we're going to change the ending to "ide." And then we're going to look at our numbers for our prefixes. So for nitrogen, I have 2. So I'm going to put the prefix. Remember, it's a prefix, so it goes in front of the element. Okay, and then for fluorine, I just remember have that invisible 1. And so 1 is mono. So dinitrogen monofluoride. The next one, I have sulfur, and I have oxygen, which is oxide. And since I have 2 of each, they each get a di. So disulfur dioxide. Here I have silicon. Okay, and then I have oxygen again, so that's oxide. Okay, and because there's only 1 silicon, we kind of have an exception with our mono prefix. We are never going to use this. Never use on first element. Okay, so here, because I only have 1 silicon, I'm actually not going to put a prefix. Okay, it's just silicon. So then when I have oxygen, though, I have 2, so I'm still going to use my di. So I end up with silicon dioxide. So with number 4, now we're writing our formula. Okay, I know I have sulfur, but when I go to figure out how many, I can see that there's no prefix. So I know that that means it has to be a mono, because mono is the only time that I won't have a prefix in front of my first element. So I'm just going to have 1. And then my next element is oxide, so that's oxygen, and then hept means 7. Okay, my next element is selenium. Tetra means 4. Then I have iodide, so that's iodine, and then di is 2. Okay, then I have nitrogen. There's 2 of them. And then oxygen, and there's just 1 because it's mono. Okay, so I was trying to make sure I don't have anything else to say. So that's really all there is with covalence. It's not quite as there's not really as much going on as with ionics. So next, complete your independent practice. It's on the back of the notes. Okay, make sure you submit everything to Schoology. So even if you're not submitting it, like if you didn't type in the word, if you wrote it and you need to take a picture, make sure you submit every single page. It doesn't do me any good to just look at the first page where your name is, where there doesn't actually show any work. Okay, I want to see everything that you wrote down. And then don't forget, you also have the homework module to do. So hopefully today, if you didn't finish the covalent homework module, you can the ionic homework module, you can do that from yesterday too. So make sure you've completed both of them by the end of the day. And then other than that, let me know if you have any questions. And